You can serve the food first.
This is the Philippine
Delivery,
culture.
delivery. Oh yes, yeah.
In my university right now, you can together with Dr. Koo, and usually we do not have any food already in at our site for a meeting
Oh,
unless we come up with our own money, and we share with our friends or colleagues during the meeting. We have to pay out by our own if you want to have a food. So
really?
yes. So LaSalle is good that every time I attended the meeting, and then we have plenty of food, and even we can take away. So, but in Malaysia here, not the case, and it's good that we won't gain weight easily.
Yeah, it's good. At least you know that they attend the meeting, not for the food.
Yeah,
You
exactly.
know, if we don't serve food in the Philippines, nobody will come.
Really? Yeah, I go to
Yeah,
Philippines like
well,
that.
that's always
Yeah,
that's what
I go
people
to
look. Okay, they look forward always to the food. During
perhaps.
meetings. But this
Uh-huh.
time we're on deliveries. How's the situation in Malaysia now?
Very good.
COVID, yes.
Yeah, very good. Is under control, and every day we only have like maybe less than 10, or maximum is only less than 20. Like every day is already around more than a month.
Oh,
It's
great.
under control. It's under control. Our government did a good job, and also the citizens. Majority of the citizens, the minority recently caused some some
Hmm.
cases happen, which is some of the people they come. There's one man, he came back from India, and he was assigned to be quarantined at home, but he doesn't do his responsibility. So he actually opened up a shop, I mean a food shop, and then he spreaded the viruses to, I think now is around 30 people.
Oh,
Yeah, so he's very
so
irresponsible person. Yes, he should stay at
what
home.
he was selling the virus.
Exactly.
So
Yes,
it was spreading the virus and still making money.
true. So
Okay.
our government right now restrict the rules of the quarantine. For those who came back from the overseas, they have to be quarantined at the assigned places by the government, and they are not allowed to be quarantined at their own house anymore because they are not disciplined. Some of them are not disciplined. Yeah, and they spread the virus.
Okay.
So, mm, but so it's good actually. But they have to pay for the accommodation. I mean, if they've been assigned to a hotel for quarantine, they have to
Mm.
pay about 45% of the expenses, and
Mm.
another 55 is sponsored by the government, something like that. Yeah.
Okay.
Mm.
Great.
Yeah, and we do two times of the test. For the first time they touch down, for the first day when they touch down to Malaysia, and on the 13 days. The 13 days test will be based on the blood test. So it's more accurate.
Oh.
Perhaps at the first time, they were tested
Mm.
negative, but on the 13th day, they may tested positive because they are using the blood. So it's more accurate on the 13th day. So this man who back from India was tested positive on the 13th day.
Oh.
So
Oh.
yeah,
Oh dear.
initially he thought that, oh, I'm virus free because I was tested negative, right? On the first day when
Oh.
he arrived the airport. Yeah. But
Oh.
who knows? But our government do the two times test. So for the second test on the 13th day using the blood, and then it tested positive. So it's already a little bit late. He has spread the viruses to some of the people already.
Oh dear. Oh dear. Yeah.
Yeah.
So he's still there. He's still on quarantine
Uh,
in Malaysia, or
in Malaysia. Yeah.
yes.
It's near to our university. So some of our colleagues has to be stay at home whose house is near to this man's restaurant.
Hmm. Oh,
Mm,
I see.
yeah. Oh, we have okay. Cool. What's the decision? We want to wait a little bit longer.
We can start because Prof. Alvin might have another
Yeah, I'm
program.
fine. Yeah,
Yeah.
that's okay.
So, do you have other meeting after this? I mean, at the 11
Me?
or 11.
No. I'm okay.
You're
Yeah, I'm
okay.
okay. Yeah, my next meeting will be in the afternoon, so
Okay, so
I'm okay. I'm fine now. So
we
if
can
you want to wait for a while, yeah,
we
we
can
can just have a
this
maybe.
is gonna be recorded.
Okay,
We
or
record.
maybe
We
yes, this can
haven't
be
record, right?
recorded.
No, not yet. We start record after Prof start presenting, and people who cannot
Yeah.
join now, they can watch our recorded version after this.
Yeah. True. We always do the same thing that we will record the and for Malaysian, we a little bit like a Philippines. Sometime when we have the meeting, usually we will be late for 5 to 10 minutes.
At least only for 5
sorry
minutes.
for that.
And to those who have attended, can you please fill in the link in the chat box so that we can send you the e-certificate.
Yay! So Marvin, can you ask your colleagues to join? Because I think I tell to some of them in the EVSU, VSU. I mean, like
I will share the link to them.
yeah. Oh, now okay, good.
Yeah.
To support our Professor Culaba.
Yeah, it's okay. Now you can record and you can just send it, something like that. I mean, it's
Yeah.
not like in a face-to-face thing that if they are unable to attend, they miss that. Now, yes, you can have only few people. That's fine because it can easily be shared, in at a convenient time. That is really what's good about this as well. Yeah, we are getting used this online thing online. At school, you have resumed you have now classes at Perlis at the
Uh,
university now.
we have a special term right now, but it's already
Okay.
ended. So we are now we wait until the October. So our next new semester or term will be starting on the October.
All right.
Yeah.
Okay.
Yeah. So yeah. Oh, we have a few colleagues are joining now. Do you still remember our dean Farizul?
Yes. Is there, Mohammed?
Farizul, Mr. Farizul, can you please speak to talk about?
Yeah, Farizul. How
Yeah.
about
Hi,
how are
Alvin.
you,
How
Hafiz?
are you?
Nice to
How are
see
you, Prof?
you.
Nice to
I'm
see you.
fine.
Yeah.
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 At
Well,
least
thank
we're
you
all.
for. Yeah.
Yeah, thank you. Of course, also, it is a
Yeah.
good forum to share, ideas and what
Of
we
course. Of
do.
course. Yeah.
Remember,
We are.
remember, we have a plan to how we can collaborate, or So I hope we will have a chance to, at least even if
Yeah.
we are under this pandemic it's good to have something like this. Yeah, it
Yeah.
still encourages people to share ideas. And so, how are you anyway? Oh,
Well, I'm fine.
you are in your office?
Not yet. I'm still at home. There's something happened today in my home. But then, well, thank you for for agree to do this, and thank you to Dr. Ong as well. To
Oh, no
arrange
worries.
this.
Yeah.
You just thank to
I'm
Dr.
glad,
Culaba, Dr.
glad to see you.
Culaba.
Yeah, glad.
Hoping that after the pandemic we can visit Dr. Culaba.
Yeah,
We want
Philippines.
we
Yeah,
can, yeah.
yes.
him to
Yeah.
Malaysia. Yeah.
Yeah, you were supposed, yeah, you could have came here, earlier. Yeah.
Yeah.
But anyway, yes, we'll see.
Problem.
Yeah,
My
probably.
We'll
contact
see.
is still there.
Yes.
Yeah. Just wait for the end of the pandemic, and I think, yeah.
Yeah.
Yeah, I hope it ends soon.
Mm.
So,
Shall we?
yeah, we can start if you want.
So, sir, do you mind to stop the presentation first, and then let me introduce you? Okay. Good morning to all my beloved colleagues. And first of all, I would like to express my sincere gratitude to Academician Professor Alvin Culaba, who's from the Philippines, from the De La Salle University, Manila, Philippines. And also thank you so much to my manager of Center of Excellence, Biomass Utilization, Associate Professor Dr. Shahida Ismail, for giving us the freedom to invite our international expert to be in the webinar. And of course, do not forget the Dean of the School of Bioprocess Engineering, Associate Prof. Dr. Farizu, who's joining us on his very busy time. And thank you for all the friends, my colleagues, my beloved colleagues and friends and students who are in this webinar. So before we invite Professor Culaba, Dr. Culaba, to share his knowledge with us, and please allow me to introduce him. And actually, he gave me a very long curriculum vitae, and I need to make it to a short and to emphasize of his achievement. Okay. Academician Professor Dr. Alvin Culaba is a university fellow, full professor 10, because in De La Salle University, the ranking of the professor is up to level 10, and he actually is the highest level of the professor in De La Salle University. Of the Mechanical Engineering Department, Go Pengguan Chair Professor in Mechanical Engineering, Mr. and Mrs. Huang Kongqing, Chair Professor in Chemical Engineering, and Director of Center for Sustainable Development Research and Linkage, Training and Consultancy, and former Executive Vice President, the External Relations and Internationalization, De La Salle University, Philippines. So he holding many positions actually, but I could not list out all here, but this is his main task in the Philippines. So with the active research involvement, he has been appointed as visiting professor and scholar at 13 institutions from the United States of America, United Kingdom, Japan, Korea, Taiwan, and Malaysia. So he also served as consultant at the Philippine Institute for Development Studies, Philippine Center for Environmental Protection and Sustainable Development, Philippines, Philippine Investment Management Group of Companies, and UNESCO, Finland, and Estonia. So his areas of specialization include energy technology and management, life cycle assessment. I would like to emphasize here, Professor Culaba is a father of life cycle assessment in the Philippines. So management of technology, manufacturing and environmental system engineering, and cleaner production technologies. He finished Doctor of Philosophy in Mechanical Engineering from the University of Portsmouth, England in 1996, and Master of Engineering from the ASEAN Institute of Technology, Thailand. And in 1994, he obtained his Bachelor of Science in Mechanical Engineering from the Eastern Visayas State University, Tacloban, Philippines. So Professor Culaba's PhD advisor is one of the Nobel laureate, and perhaps he can introduce his professor later on, but he's a late Nobel laureate. So Academician Professor Alvin Culaba is recognized for his pioneering and significant contribution to the area of life cycle assessment, theory and applications, renewable energy systems, and alternative energy and cleaner production and technology. So he developed a diagnosis model for assessment of green productivity of manufacturing processes and utilized the life cycle assessment methodology in the analysis of biofuels as alternative transportation fuel, which helped in the formulation of the Philippines Biofuel Act of 2006. He has published over 180 papers in international journals and conferences. So he also authored a few book chapters in the life cycle assessment and environmental management. So Professor Culaba received more than 30 international and national awards, and he was named an outstanding world research by the International Association of Multidisciplinary Research in 2014, and he was awarded the USAID Strike, which is a very established fellowship, the visiting fellowship from the US in 2017, and co-lectureship for engineering by the Philippine American Academy of Science and Engineering, USA in 2018. So without further ado, I would like to invite Academician Professor Dr. Alvin Culaba to present, to share his knowledge with the title of Harnessing Algal Biomass Lab to Lab for Aquafeed Application. So let's welcome Professor Culaba.
Okay. Right. Okay. So,
Sir, you can share
Professor Ong, my
your
goodness.
presentation now.
You can see
Take your
my
time.
presentation. You can see my presentation material. Can everybody see? Can you not yet?
No.
No, we can't see it.
Please.
Hang on.
No.
Let me check. Hang on. Window. Okay. Hang on. Where is that? I cannot see the icon for. Yeah, it's there. Okay, is it there now? Can everyone see my presentation?
Yes.
Yes.
Okay, is there? Okay. Well, that was impressive, Professor Ong. I didn't know some of those information, so you know better than than me. Where did you do the research about my background? Yeah. So anyway, that was too generous. First of all, let me begin by thanking you, University Malaysia Perlis, for the invitation to speak at your research seminar for today by the invitation of Professor Dr. Ku Shahida Ku Ismail, the manager of the Center of Excellence for Biomass Utilization, and of course my very good friend Professor Dr. Lin Ong, whom I cannot say no, when she invites us, so I'm okay. So thank you anyway for the invitation, and of course, Dean, for and all the participants who uh, came here to listen to this talk. As academics, we thought that we are actually more relaxed during this pandemic because we are not required to report to our universities. But it seems that it's turning, the other way around. It seems to be very busy actually, while at home when we can easily connect, through web meetings or web seminars and all this stuff. So anyway, again, thank you to the University of Malaysia Perlis for this invitation. Um, with the Center of Excellence on Biomass Utilization at your university, I thought I would like to share, my recent work on algal biomass or lab. As most people would associate biomass, they would always think that this particular material would be used for power generation or as fuel or for as an alternative source of energy. But there are already a number of applications wherein biomass materials are also used for non power applications such as for aquafeed uh, industry. So biomass, as we all know, is an important resource and commodity, especially in our countries like the Philippines. Of course, I think also in Malaysia and similar other ASEAN, neighbors. Um, it is an organic material that comes from plants and animals. And plant biomass absorbs sun energy in a process called photosynthesis. That is why biomass of this sort are photosynthetic, materials. Primarily, biomass are sources of alternative energy, but it can also be applied, such as in food. And if we build the industry around it, it can help reduce poverty and promote social equity. And as a renewable material, it is deemed to be environmentally sustainable. There are several biomass materials that has already transcend, from what you call a generation of biomass. From the first generation of materials, these are the usual byproducts or waste of our crops, and they are used mainly for energy and biofuels. Okay, and of course, most of them are actually applicable also to food. That is why first generation materials would already always have a problem of, you know, its utilization, whether people would like to use it for food or food for fuel. So that fuel versus food debate is always, an issue for this type of materials. Then second generation materials came about. Again, many of these materials are also used, for fuel. And the third generation materials are those that have high photosynthetic efficiency, up to about 20%, as studies show. And they can easily grow, or they can easily be produced, and they can, in fact, also be cultivated. And one of those materials in this classification is your algal biomass. This algal biomass is an aquatic unicircular cellular microorganism that convert water and carbon dioxide to algal biomass with the presence of light. And these microorganisms or algae are in the size of 1 to 100 microns. So they are known as micro, algae materials. They can double their biomass within 24 hours. If you look at, here on the lower portion of this screen, this is your algae biofactory. With the aid of sunlight and carbon dioxide, your biomass material could gain, proteins, carbohydrates, and lipids. Lipids is a source of your oil, which you can convert, for fuel. If you go into the material on the macroscopic view, this is how it looks like. And when you look at on your microscope, this is how, the microalgae or the algal biomass would look like. In the Philippines, there are over 1,000 species, but very few have been studied, especially for non, energy applications. So the algal biomass is very common in areas wherein there are brackish, water. It is in the form of an algae mat. Colloquially, it is called lablab. It's lablab, no? Also known as fairy python, but commonly people would call it lablab, or the farmers or those in the aquaculture, industry. When they see this material, they would recognize this as lablab. So if you look at the left photo here on top, this is the sort of conditions that this algal biomass or lablab would thrive. As long as it is wet, it has a bit of water, it will grow naturally, and it grows very, very fast. And when the water rises up to about 6 inches, uh, the lablab actually surfaces, because they grow, at the soil, and they would usually find this lablab, at the surface of the water, and this is very common in fish, and fish ponds. And these lablab are actually a source of food for the fish. The fish eat this lablab, and the fish grows fast, and they become, big. No, so we tried to find out what constitute, this particular biomass. This biomass, or this lablab, is characterized by its complex biological composition of cyanobacteria, diatoms, filamentous algae, and other, inver- invertebrates. You can see here, that they are live, in the material. They're moving, So it's a complex, material. So that's why we needed to study, what actually constitute this particular material when it provides a lot of nutrients to the fish. if you can see here, there's a huge market for algae-based industry. For lower value products, it has over 2 trillion US dollars worth. The study has been there for some time, but certainly there's a huge market for algae biomass for carbon capture, bioremediation, and even for biofuels. But the mid-sized market, which is valued of over 5 billion US dollars, would look at higher value products that are actually marketed in the livestock industry, like for the aquaculture or fish industry. And of course, if you go up to the pyramid, then you produce even higher value added products, which has also valued at over 80 million US dollars. It may have a small market, but the value of those products, especially in chemicals, pharmaceuticals, are really huge. In the Philippines, we are an archipelagic country. Two-thirds of our country is water, only one-third is land. So you can just imagine the amount of marine resources that we have. So the aquaculture industry is an important sector in our economy. It contributes significantly to our country's food security, as well as employment and foreign exchange, earnings. Similar to our neighboring countries like Indonesia, even Thailand, Malaysia. I think we are major producers of aquaculture, products. And it has been seen, as you can show here at the lower part of the screen, how the industry has grown over the period up to the present, uh, steadily increasing. Although in recent years there has been a decline in the fisheries production of 3.2%, has been as reported by our statistical authority. The data shows. And one of the most important farmed fish in our country is the milkfish. Accounts to over a third of the share amongst the different aquaculture products. So the farmed fish is important in terms of volume, production value, and even geographic spread, of the industry around the country. At one point, it has registered a very high production at over 400,000 tons, as reported by the Food and Agricultural Organization in 2018. So as you can see in the figure here, the production has not really gone down significantly. And the photo here shows how the milkfish actually are cultivated and grown. They are actually grown in ponds, in fish ponds. They are not saltwater, fish. They are in fish ponds, brackish, water, or uh, this water which are found inland. So in milkfish production, aquafeed constitutes up to 70% of its cost. So you can just imagine, you know that in milkfish production, um, they really have to find a way to reduce the cost of uh, the feed, of the aquafeed. It is something that costs a lot. The price of commercial and formulated feeds are really high. They are expensive, primarily due to its raw materials. And the raw materials in the production of feeds would account to between 60 to 70%. But there are natural based feeds that actually abound. They are available. However, its sustainability and the supply issues are actually the major concern. If you want to utilize natural based feeds, such as those coming from algal biomass. So we are actually faced with some really serious challenges if we want to harness lab biomass for non-power applications. Here we study on how we can utilize lab for aquafeed application. So the lab grows on soil, as you can see here in this video on the left side of the screen. You can see how lab actually grows. It's attached to the soil, and they separate. No, when they are heated or under the sun, the lab material separates from the soil, as you can see here, and they actually settle at the surface of the pond water. Normally, uh, it would best uh, you know uh, have lab settle at the surface when the depth of the water is around 5 to 6 inches. So because the heat or the sun's light could penetrate easily to the ground, which will allow the lab to separate from the soil, as you can see here. So if the water is already too high, then it slows down that process of separation from the soil. So if you are going to cultivate lab, you have to maintain around 5 to 6 inches of depth of your water, so that you can effectively allow the lab from the soil to separate and settle at the at the surface. And when they are at the surface, that's the time that they can be eaten easily by the fish, or you can collect the lab. On your right, uh, uh, shows the lab actually easily dissolving on the water. Here, this is taken when it was raining, and you can see the lab is slowly disintegrating, and soon when the rain really falls hard, then the lab will disappear. So this is actually what we want to avoid. We want to be able to collect, the lab before they disappear, so that you can still have the lab fed to your fish even during this time or this condition. So the intermittency of the supply of lab is, another problem that is actually presented to us or to the industry when looking at natural uh, feed materials as your source for your aqua feed. So we try to study this lab or algal, biomass from a site which is about 2 hours drive from Manila, roughly about 43 miles or around 77 kilometers away. This is in Bulacan. It is a province just adjacent to the metropolitan Manila area. This is where many of the fish ponds are located with proximity to Manila. So a lot of our milk fish are actually sourced from the fish ponds in this area. That is why we chose this as our, study site. So the first challenge that or problem that we have to address in harnessing algal biomass is to be able to collect it. As I have mentioned, earlier, um, if you want to utilize lab, you have to be able to collect it. Otherwise, with the weather like what we have here in the Philippines, where it rains half of the year, then you would normally have no supply of lab for that particular period. In other words, you have no natural feed to provide for your fish. Uh, in that particular case, you will have to purchase, the commercial ones or the formulated diet, which is actually expensive, and that will add a significant cost to your, production of your fish. So we have to look at, how we can address this particular problem, because if we are to harvest the lab and you have to do that manually, this is how you are going to do it. So you can see, these farmers would have to go to the pond and manually collect, your algal biomass, and it would require 4 to 5 people to finish the collection of your lab, in a particular area like half a hectare of a fish pond. So that is how you have to deal with, in the collection or the harvesting of your lab. So this particular problem has been presented to us by the industry, by a company, on how they can utilize this particular material. So we thought of designing some harvesters, and we came up with some initial designs and prototypes. And these are the two of the harvester designs that we have done, and we tested it on the in the pond. This is like, a uh, a mechanism that actually collects the fund. This is a collecting uh, you know uh, uh, machine, and it actually this actually moves vertically, and collects the algal biomass or the lab present here, but this is done, manually. And the problem here is, as you finish collection in that particular area, you need to move the entire machine to the next adjacent site, and then again you collect, you allow this to move along this uh, machine, and collects the lab. So this is tedious and slow, and we try to introduce another like a bucket, that type of collector, but similar to the previous one. This is also, a bit slow collecting a machine. And once you have finished, in a particular area, you need to move this machine to another area. And this is a bit, heavy, and it will take some people, to move this from one area, to the other. So we have to address, the problems presented by these two mechanical designs. Although we could design it in a semi-automated manner, but still we thought that that was not a very feasible design. So instead, we try to come up with another modular design, which we can possibly fully automate, and introduce some more advanced methods, like digital signal processing or vision system or AI, that would allow more intelligence and automation for this particular uh, system. So this led us to this new design. As you can see here, it has several, components, component parts that would allow, the machine to identify and determine, the lab, and also collect without human, intervention. So we thought of incorporating, parts like, here you can see a camera for the vision, so that it can detect, the algal biomass, and you can collect it through this 125 micron wire mesh, which is driven by a conveyor drive motor. And you have several component box at the back, that would allow more navigation and the propulsion and controls, in this particular case. So from that particular design, we had to come up again with a prototype. Here you can see this, the middle photo here shows the prototype design of this uh, harvester, which we actually envision to be fully automated or intelligent. And we initially tested this on a swimming pool, just to have a proof of concept. You can see that we can allow the machine to move and navigate, and you know prove that we can actually uh, control the uh, the machine or the harvester using its uh, control mechanism, as well as its camera for its vision system. So this is on a swimming pool, just to show the proof of concept for the design. So there are several iterations on the design to ensure that it addresses the problems of the two initial mechanical designs. So what you can see here is the control design architecture and the control setup. You can see at the lower portion of this screen, and on the right side is the propulsion and steering mechanism, design. This allows a smooth, navigation of the machine, so that it can move slow or fast according to your program speed. And you have your servo and the brushless motor that will provide you the thrust, as the machine actually moves around the area or the pond. We also wanted to have a an operation that can be controlled remotely. uh, you can use the traditional, joystick. We can actually buy one of those off the shelf. But we also wanted to design, the harvester in a more autonomous manner. So we incorporate automation from this, and this is how we uh, try to actually look at and program the waypoint mission to allow the navigation of the machine. So here you can see at your left is the program. It is a round, waypoint mission. In other words, you program it in a circular manner. If if you can allow the or control the machine to move around this particular predetermined, direction. So here you can see that based on the program, the machine is able to move around in circular manner. So if your waypoint mission is to move straight, ahead in your pond, then you can program that, and the machine will go actually straight ahead. And you can also program it to work back. Then the machine will do that. So what it shows here is a programmable, mission, waypoint mission, so that you can actually control and program where you want your machine to move, so that you can actually collect effectively, the lab on the fish pond. Okay. Um, Next slide here is you can see the programming for the vision system. You can see here at the top of the machine that we attach the camera, which will actually allow you to visualize the lab biomass present on the pond. Okay. And you can program this, as you can see here on the leftmost of this screen. You are able to see the different lab present on the fish pond. And after programming, you can do a predicted material, which are shown here in red, colors, which actually allows you to look for the proper material. Because sometimes materials present are not lab, they are debris, or there are waste, there are what plastics, or and therefore the machine would not collect that particular material. Okay. So this is how the lab machine looks like when it collects the lab here. You can see here the researcher is controlling remotely, the lab. This is not on autonomous mode, but on a remote control mechanism. So the actual harvesting is shown here in this slide. So before the run, this is the amount of lab actually present on the pond. And after the first run, you can see that there are already lab removed after the harvester has passed the first time, and then after the second run, more lab actually are collected. And for after run 3, you can see that there are already less lab remaining on the pond. And after run 4, more and more lab are collected. And after run 5, you can see that there are already few lab left in the pond. So if you continue to run it, then you can really completely collect, or harvest the lab. So here you can see the automated and the manual harvesting, the difference, of how the collection of the lab is done. On the left side, you can see the automated machine collecting the lab, while on the rightmost, you can see the farmer manually collecting, the lab. So you can see here that you can actually program your vision, your machine. You can control it. In this particular case, in the leftmost, uh, uh, figure here, video, you can see that it is moving straight on a path. So those that are actually on its path are actually collected. Okay, and you can see on the second video that it goes straight ahead. And this is programmed that way. That's the waypoint mission that you have programmed your machine to do. So it will actually run up to the end of the pond, and it can actually reverse back and go to the next area that the lab but normally the lab will return back to the area. And the lab harvester will be able to collect that as soon as it goes back and passes through again that particular path. But while you can see here the rightmost, how collection by the farmers is done. This is tedious, and sometimes the weather already gets bad, and before you can even collect the lab, they're already gone. So that's the problem. That's why you will need a couple of other people spread around the area to collect, and you know how much it costs for a farmer. It is also a minimum wage at 500 pesos. That's probably what 500 pesos is about $10 a day to collect per person. And that will add on to the cost of production of the aqua of your fish or your milk fish. So performance testing was done. So with the same area, using the lab machine, it would take only 5 minutes to collect, the algal biomass. And for manual, for 4 to 5 people, it would take 30 minutes. You can imagine, the significant reduction of the time that you can collect your, algal biomass, which you can actually store and dry eventually, and you can use it when the weather is not so good and the availability of your lab on the pond is not actually present. So that's the result of our research on the automated lab harvester. So there's still a lot of opportunities for research that you can do by incorporating artificial intelligence and other techniques to improve the performance of the harvester. Now we are faced with a second problem in utilizing algal biomass. As I have mentioned earlier, once you are able to collect your material, you have to be able to dry it so that you can set it aside when the need arises. Your Aquafeed is available for you. So that is actually why it was important for us to be able to collect or harvest the lab, and now we have the problem of drying it. So we look at several drying technologies, and one of those is the convective drying. In this particular drying method, it transfers heat energy through the contact of preheated fluid with heated substance. So we place the specimen or the wet lab collected inside the dryer, as shown here in green color. So you place this inside this drying, and the dryer automatically detects the weight changes as it undergoes drying. So we make some measurement of the weight of the material up to the time that the specimen is 100% dry, or there's no more moisture content present. This is one of the most conventional methods of drying, as has already been demonstrated in some studies, that you find in the literature. Another drying technology that we looked at and then we have tested is the microwave vacuum drying. Drying is quick, and it really shortens significantly the drying period. However, the main problem is the energy consumption is very high. So for this type of technology, it is energy intensive. But nonetheless, we did an experiment on the effectiveness of drying, using microwave vacuum. Um, for solar drying, it took us a long time to design a solar dryer. And this is one of the dryers that we have actually fabricated, and we have tested also the biomass in this particular dryer. So what is obvious is that the solar dryer has the temperature feedback, and it has to be maintained inside the chamber, and this is a function actually of the effectiveness of the drying to the weather, because if you really utilize the natural solar energy or energy from the sun, then you can only do that during good weather. Otherwise, you can simulate the solar drying inside the lab by providing simulated light. You can install, fluorescent lamps, to simulate the amount of solar energy, or the lumens necessary to dry actually the biomass. But while the power consumption is low, or if you do it outside under solar energy, then you don't have to use any power or electricity at all. But the solar drying is a bit, slow in this case. So in this particular slide, uh, we present the comparative analysis of the various drying, technology. And as you can see here, from the drying time, uh, it takes really a long time for solar dryer to completely dry the material, the biomass. And for convective drying, it is actually much lower, but still higher than using a microwave vacuum dryer. So from the drying perspective, the microwave vacuum drying will give you a very fast drying time, about 2 hours, uh, compared to over 2 hours for convective drying. But in terms of drying, capacity, uh, the uh, the drying by microwave vacuum is far higher, primarily because it actually allows you more material to be dried due to the faster drying time, no, for this technology. But for drying uh, using convective dryer, it is lower than microwave vacuum drying, but still better than solar, drying. But it is in the specific energy consumption that you can see on the right most of this screen, that the microwave vacuum drying would require over 90 kilowatt hour per kilogram of biomass, to dry, compared to solar, which is only close to 12 kilowatt hour per kilogram, uh, and the convective drying, which is over 26, kilowatt hour per kilogram of material. So on the basis of these three, parameters monitored and studied, the convective drying is the preferred technology that we utilized. And you can see here at the top right section, this is the dried or the powder biomass, algal, biomass. Okay, so we also try to study the effect of the convective oven temperature to the protein content. So the optimal setting would be at 60 degrees Celsius, and the sample thickness of the lab must be 3.45, millimeter. And it has been shown that lower temperatures would reduce biodegradation of the material. So these are the results of our tests based on the protein effect on the protein content and the energy consumption. And this lead us to the next problem that we have at hand, which is trying to find out what actually constitutes the nutrients of lablab, because they are really eaten, by the fish or by the milkfish, and they grow easily and gain weight. So we have there's no information in the literature, so we have to do an analysis, uh, nutrient and mineral content, analysis, which is shown in this figure. So you can see here that the nutrients are not really very high from the point of view of crude protein here, and the fat, as well as the carbohydrates, which is here the fiber. In fact, the high the content, the high, I mean, the ash content is very high, primarily because when we collected, the sample at that time, we're not actually using the the automated system. So we were able to collect also a high degree of soil, that were mixed with the lab biomass. Uh, okay, but in the left, on the right side, are the mineral content. So it has zinc, manganese, iron, and magnesium, minerals, which are actually the main mineral content or nutrient of this lab. And that explains why, the lab, is a good material as an aqua feed for milkfish fry up to 30 days, which are already fingerlings. No? So we have tested the the powder biomass material to milkfish fry up to 30 days. And it turned out to be effective. So there were four treatments done. Uh, Treatment four is the formulated diet at 100% zero lab. And then we varied it with a 25% reduction. Uh, sorry, we also had 100% dried lab, which is treatment number three, and we reduced it 25%, substituted it with uh, 25% lab powder, and 75% formulated diet. And we tried also at 50% formulated diet and 50% lab powder. It turned out from the results of the feeding trials, after several experiments, that the treatment one, which has a 25% substitution of the formulated diet, would actually have an average daily growth rate of 0.003 grams per day, which come about the same as a 100% formulated diet. So we thought that this is the best formulation where you can introduce lab. So at 25% lab powder, you can actually provide an aquafeed, which will result in a good growth the uh, of the milkfish. And finally, we also try to establish the viability of lab as an aquafeed for milkfish. And we did some cost analysis. We developed a model, and it turned out that for treatment number one at 75% formulated feed and 25% formulated diet, powder lab, it will generate a reduced cost of 47.29 peso. This is almost $1 per kilogram of feed. I mean kilogram of fish that you will actually produce, compared to a formulated diet, which is 52.2, which is actually about $1, per kilogram. So in terms of energy cost, also we tried to analyze, considering the harvester, the dryer. It turned out to be costing the lab at around 32.6 peso. That is a little over, let's say, $0.6 per kilogram, of fish or output. So to make the industry, the aqua feed industry, viable with the use of natural feed sources like algal biomass. You would need, you know, an ecosystem to involve all the major stakeholders so that you can sustain the supply and demand, as well as the innovation in producing algal biomass for aquafeed, you know, application. And this is what we want to establish in the algae, you know, bio innovation global hub to help the aquaculture industry, so that with the utilization of natural sources of biomass that can be produced or manufactured for aquafeed. And this will help significantly, you know, the farmers and the aquafeed producers in terms of the significant reduction on the aquafeed material. Okay. So in this research, there are quite a number of people, faculty and students doing the research, from the machine, from the harvester to the drying to the feeding trial, and to the cost analysis. So people come from various disciplines and in engineering. So from mechanical to chemical to electronics, manufacturing, industrial engineering, economics, even social scientists, because we are dealing with farmers here, how they can actually, address the social issues. And of course, this work was funded by the government, Ministry of Science and Technology, in cooperation with our company, with an aquafeed company based in Manila, and of course the university, the University Research Coordination Office of De La Salle University, and my Algae Bioinnovation Global Hub. Okay, so that ends my presentation, and I'm happy to entertain questions if there are any. And if you want also to contact me, you can reach me at this email, and we'll be more than happy to answer your questions. Or you may check our website, www.abighub.org. So once again, thank you so much to the University Malaysia Perlis, to the Dean and Professor Ong, and of course Professor Hafiz. So thank you so much, and good morning.
Okay, thank you so much, Professor Culaba. And we open for the questions and answer right now? Is anyone have questions to Professor Culaba?
I have one question.
Yay!
Okay, I'm more interested on the life cycle analysis. So
Okay.
for the so have you done any life cycle analysis for the algae biomass to fish feed?
Biomass.
Uh-uh.
Sorry, who is that again? But anyway, yeah.
Dr. Kuku.
Anyway, yeah. We have not done any LCA yet. We were faced with those four problems that we have to deal with. This has been a study for the last 18 months. So there are opportunities, that we can do. Probably a life cycle analysis of the material, can be done. The thing is, unless we are able to really study the material itself, and in fact, at the start, nobody has an idea of what constitutes lab. Why fish likes it, why they eat it, and why fish grows easily, with those lab. So you can do an LCA study once you have all the necessary data on the material, and it will not be difficult, to look at the entire life cycle from the cultivation of the lab, because lab can be actually cultivated. We also wanted actually we would have wanted to actually study how lab actually grows, no, or whether we can control the parameters, like for example the soil, the water, the depth of the water, or the amount of water, or the other environmental factors that would actually affect the growth of the lab. What we actually has considered in this study was only the natural growth of the lab. As you can see, the lab grows naturally. It grows on top of the soil, and it separates, and settles at the top of the. So there are many opportunities still, no, to do a study or to do some research on this. I just do not know in Malaysia whether you have this similar material you can find in your fish ponds or in brackish water areas. I don't know. And if you have, maybe you can also do similar investigation or similar study, for the material. Okay. I hope I've answered your question. Yeah.
Yes, thank you.
Thank you. Thank you, Christian.
Any more questions from the audience, from the friends here, or
So
Excuse me,
let me,
Professor.
yeah, sure, Go ahead. Who's
Excuse me,
that?
Professor. I'm
Moni?
from
Yes, sure.
yeah. My name is Man Yi. I'm from the
Mani,
Faculty
okay.
of Technologies of UniMAPs. I'm under
Okay.
the process, the industrial chemical process. So since this thing, the lab is algae considered as one type of biomass. I'm actually do some research about biomass in the new renewable energy. So may I ask about did any research about this lab can be used in uh, the in how in to
In
create
energy,
the new
to
energy
produce
or
energy.
to replace the fossil fuel.
Okay. The answer is, based on our result, the answer is no. Because
Mm,
in our content analysis, it has no lipid content. So,
I
but
see.
again, okay, but again, Ms. Manu, maybe because lab biomass varies from one place to the other, and we were only considering a particular source here, and this is not conclusive that indeed there is no lipid content. But in our particular study here, there was no lipid content, and therefore there's no opportunity for us to use it for fuel, for biofuel. But
I
you may want
see.
to, yes.
Mm.
If you can see on the screen, I don't know if you is
Yeah,
it
yeah,
there on the
yeah.
screen? Yeah. We didn't come out with any oil content. But remember, there are several biomass or algae materials or microalgae materials or species which have very high lipid content. and I'm sure they are available in Malaysia. However, in the case of Lab, now we have it's confirmed based on our study that it is not a material suitable for use for biofuel or for fuel use. Yeah. Okay.
Thanks a lot.
But again, yeah.
Mm.
But
Thanks a
try
lot.
to investigate. Yeah. Try to collect. Samples. We might find materials which may have some lipid content. You have to test for lipid content if you want to actually find out if that particular material would be suitable for biofuel production. Okay. Thank you.
Perhaps you can allow one more question.
Yeah.
Yeah. Oh,
So okay, go ahead.
Sir, go ahead. Actually, I would like to tell you that we have our friends here from India, Myanmar, and of
Okay.
course, your students from the Philippines are listening to you right now. Yeah, we have Dr. Ramya from India, actually. She's one of our friends here also, our Southeast Asian family members. Okay.
Thank you
Dr.
so
Ramya,
much.
yeah. Okay, welcome to the webinar.
Yeah.
Any
Yeah,
more
I
questions?
know. Yeah.
If not, I will
Yeah.
ask. Or,
Yes.
sir, you want to
If
add some more
otherwise, I'll be the one to ask. Okay, go ahead.
So you want to add some more points before
Before I
I
ask.
have the question? Before I ask. Do you, because you want to add some points, right? Yeah.
Hello?
Hi, sir. Yeah.
No, I was just about to ask, how's the aquaculture industry in Malaysia?
Yes, we have.
I know you grow milkfish, although milkfish is it's locally known as bangus, no? Probably Professor Ong, you must have tasted it already or eaten it already. So, but it's very very popular, But I don't know in Malaysia whether you grow that, and whether your fish also use or utilize natural feeds like lab.
Yeah. I think basically I'm not really good in the aquaculture, but I know just a little bit about I'm not really sure that they using the lap or the algae for the aqua feed or not, because I think there is a professor from but I think he already retired from the school of our Professor Ku's school, and he's very famous in aqua feed research. And I'm not very sure yet, but this can be really interested, can also apply in Malaysia, I believe that. And actually, there's one of my question from the aqua feed that you mentioned just now. Can you show your slide that you are testing a few samples, and then with the different nutrition together? I mean, almost the end of your slides.
Yeah. I'll show that. Okay, that's it.
No, one more. Next slide.
Yes, feeding trial.
One more. Yes. Okay, the feeding trial. Because on the treatment one, you have treatment 1, 3, and 4, the formulated diet, and from the survival percentage, I mean, I think it's the milkfish survival, right?
Yes,
and
right.
Yeah, so the 75% of the formulated diet plus the 25% of your the dried lap, and the survival percentage of the milkfish is 35, while the formulated diet is 45. So will eat, because it seems a little bit like a 10% lower of the survival for the milkfish, while it's feeding with the treatment, I mean on the formulation on the treatment one. So
Okay.
is there any, is that
An
fulfilled?
explanation? Explanation?
Yeah, that
Yes. Actually, thank you for that question. But you see, that particular test, is already on the 60th day. That's already 2 months. But remember when I showed you earlier that the results of our, was actually we found out that it is up to the 30th day. In this screen you can see the 30-day fingerling. So if you look at here from the results, on the 30th day, you would have, okay, even at the 38th day,
yeah.
your survival, for terminal 1 is still 45, percent, compared to the treatment, at 60%. And of course, for formulated diet is always, very high. But on the 30th, we have concluded that the most feasible to utilize lab would be up to the 30th day only, fingerlings, up to the 30th day, which will actually give you an average daily growth, which is actually the main indicator for the aquaculture industry, for the aquafeed, the ADG per day. So because in a formulated diet, as you can see in this particular figure here on the left portion of the screen, for a formulated diet, the average daily growth is actually at 0.003 grams, per day, which actually for treatment 1, it could actually match, the ADG grams per day. So considering all other factors, that you monitor, the survival, the other fee, the treatment 1, which is actually a 75 to 25% mix of the formulated diet to your lab, comes out to be the preferred, combination. So for this particular study, our conclusion points to the treatment 1 as the preferred combination of a mix of your formulated diet to your 25% substitution. And this has been confirmed because when we look at uh, uh, the cost of while it would have been better to use a 50% lab substitution, and the cost will reduce much lower than the treatment 1. But the industry is more particular about the growth of the lab, because this is where they make more money. Normally, they would have a high also death, or low. They also have deaths, of fish. That's very common, to the industry. That is why they could not look at longer than 30 days for the use of lab, because it was at this stage that the ADG, the average daily growth, was already matching the ADG for formulated diet. The formulated diet is the one which is commercially, available. So if you can have a mix that a substituted, natural feed, and that could match the ADG per day, that is actually what the industry would prefer to have, and not on the basis of the percentage of survival.
Okay.
That's the explanation. Okay.
Oh, It's good. Thank
Thank
you,
you.
sir.
Thank
So,
you, Professor Lin.
uh, okay. Thank you so much, Professor Culaba, and thank you so much for the very informative and fruitful information shared. I mean, by you, and we actually, this is a very good idea that we actually also we can be implement in Malaysia. I believe this research idea is very fantastic, and I don't think it's just can be able to apply to the aqua feed, but perhaps with the nutritions available in the lab, and we can actually use it for other uh, application as well, right? Instead of maybe for the fishes, but I'm not sure for the shrimp, for other sea creatures or other business in the Asian country, and perhaps it can be go for as the pharmaceutical application, the supplements with the use of this. I think the lab. I think it can have a lot of potential applications also apply in our food if everything is safe to be consumed, right? So, what do you think,
Yeah.
Professor Kula? Is this microalgae is safe to be consumed by the human being?
Well,
Yeah,
the
yeah,
fact that we eat milkfish
yeah.
and you eat what the fish eats, so it's a more of the nutrient content that we are more interested in, because if
Exactly.
you are going to buy the fish, for example, you just don't want any feed material that would be taken by the fish, which
Mhm.
humans will have to eat and will give nutrition to to our bodies. If we
Yes.
are able to establish that
Mm-mm.
we can substitute formulated feeds 100% by
Mm.
a natural material like lablab,
Mm.
then it can now be proven that the fish that gives us a lot of protein and other minerals to our human body
Mm.
is actually given a lot of nutrients by a natural source, from a natural source like lablab. So
Exactly.
I don't know whether we can directly consume lablab and not eat any more fish. Don't buy fish, just get lablab and eat it. But we are not fish. We are not fish.
Yeah.
So we don't know. We have to study more on the nutritional content of the material. But what we
Yeah.
know now, is there is a substantial amount of
Mm.
nutrient
Mm.
that is available for this material to be consumed by milkfish in this
Mm.
particular study. We can
Yeah.
try it to
Yeah.
other aquaculture products, but I
Yeah.
hope
And
we can
mm.
consume it directly from the pond without having to feed it first to the fish, and
Yeah.
so it will require more studies, of course.
Yeah,
Yes.
and the skincare product as well, I think. So we actually
Yes.
in University Malaysia Perlis, we have some of our colleagues here are, I mean, in University Malaysia Perlis, they are the food scientists. Perhaps we can link them together and work together with you, and to have a more detailed, I mean, experiment or research on the nutrition part, and then we perhaps can expand the usage of the lab in the near future.
Yes. Yeah. It
Yeah.
can be
Okay.
utilized for nutraceutical, probably,
Yeah.
which is again, a higher value added, product. But again, yeah, let's collaborate. Yeah, with there's a lot of researchers here around. Thank you so much, our C family. Thank you, Nilar, Marvin. Thank you, Andres here. Also, thank
Yep.
you. Yeah, let's probably have
Dr. Fong,
Hello.
opportunity to
time
collaborate.
permits, I have a small
Hi, Dr.
query.
Ong.
Yes.
Hi,
Yeah,
Remya.
Hello, how are you?
that's Andres. Yeah, our
Nice to
friend.
see you again.
Yes,
We have
nice to
Ali.
see you all again.
Yeah, and
Yes.
do Dr. Koo, do you want to take a picture for all of us here?
Yes,
Before
please include me, please. I can. You can see me.
and yes, and
Can I be
please
seen?
every friends here, can you turn on your camera?
Okay, put
us-
on your camera. Now I can see your faces, but I
Can you,
can't see mine.
how about me? Can you see me?
Oh, how are you, Nilar?
Okay,
Yes.
bye.
Si Andres, Marvin.
See you, Andres. You're very fit now. I know.
Oh, thank you.
One,
Oh yeah. Oh, exercising ah.
three.
Si Marvin, ba't wala? Marvin, nasan ka?
I'm here, sir.
Oh, wala ka sa wala kang video.
Okay, done. All right.
Yeah.
Thank you.
Anyway,
Thank you, Ali, for
yeah,
joining.
thank you everyone.
So, Dr. Ong, this
Yeah.
video will be available for the students. So probably this is recorded, right?
Sorry, Remya, again.
This video will be available later on because this is a very nice presentation and will
Yes.
be helpful for the people who are working in microalgae.
Yes.
How do we send the video to you?
It's okay, Kuku. You can share to me, then I will share it with our C friend.
Okay, we upload in Facebook.
Yes, that will be great.
Yeah.
And a small question, Professor Culaba, like we are also doing this microalgae cultivation here for wastewater treatment. And the same way,
Yeah.
if you think of biofuel production from microalgae, the issue is with higher ash content.
Oh yes, yeah. Sure, Dr.
yeah,
Remya. Yeah.
Yeah,
Let's
so your
look at
team is working on how to improve or decrease the ash content or increasing the oil
yes,
content.
yes. Yeah. Yeah, please do some investigations also on your end, and we can probably share results. At the moment, we are limited to because we need also to apply for some patent protection for the harvester. That's why we couldn't really make a lot of information public. But yes, we can explore collaboration, and we can compare our results, and let us see if we can do something and move towards nutraceutical application than aquafeed application.
Prof, what's the price of the harvester? The
The
price.
price.
Harvester,
Yeah.
the price?
Yeah, yeah.
Yes.
The price? Well, it's not available commercially yet,
Yeah.
but it cost us. Hang on. What was it? Andres? What's the equivalent? That's about what? 30,000.
Oh, okay.
Less than
Well,
less than
this does not
$100.
include programming and everything, but the hardware
Yes.
and the harvester itself is roughly around 450 USD.
450.
450.
Let's say $500. Let us say
Okay.
$500. Yes, but it doesn't include the programming, because putting more intelligence to the machine, that is where you will have to have more value added, knowledge, or added over there. The mechanical side is simple, but the intelligence that you put into the machine, with those cameras and the programming, the navigation, is the one that probably would cost a little. But because we have our researchers, we don't have to pay them. That's the beauty of the teachers when you have researchers with you. So yeah, but that is a very very good machine that the farmers or the industry can utilize to collect and I think you can even use that to collect other forms of biomass, not
Exactly.
only even waste floating on the waters. I think we can now use it to collect it. We can, you know, especially in a more deeper part of the waters or sea. So you don't have to have people down there. You can use this machine because it can go as far as you can program it. Okay. So
Okay.
yeah, that's an interesting part. The most challenging of our study actually was on the harvester
Mm.
part. Yes. So thank you for
Okay.
that question. Yeah.
Well, okay. So we have to say goodbye then. Although I don't
Yeah,
want to
you
say
can serve
goodbye.
the food now. Yeah.
To go stop the food now. Okay.
So thank you, Prof. Alvin, for accepting our invitation, and probably we will set another research talk online. Maybe from
Sure.
our
Anytime.
friends in WISE as well. So thank you.
Yes. Professor Ong can invite many people there.
No. Yes, we can
She
maybe
can
perhaps
invite anyone.
Professor Remya from India
Yeah.
later on. Okay. So,
Definitely my pleasure.
Sure.
Yeah.
see you, Prof. See you, Sir Alvin. Take care. And Andres,
Sure.
take care. Marvin, take care.
Yeah.
And Professor Remya, take care. And Mila also take care.
Thank you.
Thank you. Thank you.
Thank
Yeah.
you. Stay safe and healthy, everyone.
Yes.
Bye-bye.
And
Bye.
ingat
Thank
po.
you so much.
Thank you so
Bye.
much.
Okay. Thank you. Thank you, Lynn. Thank you, Dr.
Thank you,
Isabel.